All right, we have the hyperbola, which is 7.2. It's another conic section, and you remember the definition for the ellipse was the set of all points such that the sum of the differences stayed the same. For the hyperbola, it's the set of all points such that the difference in the distances from two fixed points stays the same. So we have a hyperbola. Both of these are horizontal that you see here. Again, they have foci, only now they're outside the hyperbola. We have vertices, just like we did before. We have a center. And this time we have what's called the transverse axis. And again, both of these are horizontal. So there's a horizontal. Now our equation, as you can imagine, is much like the elliptical equation, only this time, instead of adding them, we will be subtracting them. X squared over a squared minus y squared over b squared for the horizontal. And then for the vertical, we have the y's going first. Okay? So horizontal and vertical. And this time, the relationship is a squared plus b squared equals c squared. So we can always figure out the distances a, b, and c using that relationship this time. And then, of course, there's the diagram of a squared plus b squared equals c squared. So which one of these is this vertical on the x-axis or horizontal on the y-axis? Make your choice. Pause here. All right, and this one, the y is first, so this one is vertical. And this one, the x is first, so this one is horizontal. All right. Now, what can we learn from the standard form? Well, pretty much everything we want. You can see this one is horizontal because the x is first. We know that a is 4 because it's the square root of 16. So you go 4 this way and 4 that way to get to the vertices. You can tell b is 3. We'll look at that in a moment. And then c is going to be c squared equals 16 plus 9. So c is going to be, c squared is 25, c is 5. So 5 and minus 5 for c. So easy enough to just read it. And then you can see this similar one, only this one's vertical. You know it's vertical because the y value is first. All right, so when you're doing a graph, it's a lot like what we did with the ellipses. Okay, you do your vertices here, and then you do your b values on the other axis. And then those determine a box. As you can see, they have the box drawn out for you. And then you draw the diagonals of the box. The diagonals of the box are the asymptotes. And then when you go to draw in the hyperbola, you just have to approach the asymptotes, see? Of course, theirs is a lot prettier than mine, but that's what you do. Draw your 4 points, make a box, diagonals of the box, and then draw the hyperbola. All right. So we're going to graph, find the vertices, and locate the foci for the equation x squared over 36 minus y squared over 13 equals 1. So we know it's centered. at 0, 0. We know it is horizontal because the x is first. We know a is 6. We know b is the square root of 13, which I checked on my calculator, and I got around 3.6. So we're going to graph it. We start at 0, the center, and horizontally we go 6 and 6. Vertically we go 3.6, 1, 2, 3.6, 1, 2, 3.6, and then we draw out a lovely box. And wish I had straight edge, but I don't. And then we look at the diagonals of the box. Yeah, straight edge would do me a lot of good. All right, and then you just take, this one is horizontal. So we graph it approaching the asymptotes on the horizontal. And then the foci are the last thing, and that's c squared equals a squared plus b squared, which equals 49. So c is plus or minus 7. So 7 and 7. So we have our points for the vertices are plus or minus 6, 0 for the vertices, and plus or minus 7, 0 for the foci. All right, easy enough. Draw it out. Couple extra steps, drawing the diagonals and then sketching that in. All right, now, what if we have to go backwards? Find the standard form of the equation if you know the foci are at -4 and 4, and the vertices are at -3 and 3. So I always like to have a look at that, -4, 0, and 4, 0, -4, 0, and 4, 0, and then -3 and 3. So we know that a equals 3, and we know that c equals 4, and we know that c squared equals a squared plus b squared. So we know 16 equals 9 plus b squared, so b squared must be 7. All right, so that is all we need. We don't have to go any further. So we know the equation is going to be x squared, and it's horizontal, over a squared, which is 9, minus y squared over b squared, which is 7, equals 1.